all of us will build up this sticky little protein that I call amyloid beta. But not all of us will build up so much of it that we will short-circuit our nerve cells and become forgetful. I'm Dennis Selkoe from Boston, Massachusetts, although I originally hail from Illinois. And I'm a scientist fascinated by the riddle of brain degeneration. Right now, my official job is as the Vincent and Stella Coates Professor of Neurologic Diseases at Harvard Medical School. And at that place, which is a wonderful place to work, I direct the Center for Neurologic Diseases. Alzheimer's, Parkinson's, multiple sclerosis, a disease called amyotrophic lateral sclerosis, which is a mouthful. In our country, we call it Lou Gehrig's disease, after a famous baseball player. Those are the diseases that concern me and my colleagues in our work at Harvard Medical School. And it's a wonderful place to work, and we have a lot left to do. But the real core of my work is understanding why certain brain cells die out prematurely as we get older, and in particular, how that happens in Alzheimer's disease. We'd like to understand how it starts, and we'd like to nip it in the bud. So as a neurologist, my real goal is to not continue to see patients with Alzheimer's disease to the end of my career and tell them what I do now, which is, I'm afraid that you do have Alzheimer's disease, but there's little I can offer you. That has to stop. And what I'm anxious to do is to turn the good science that my colleagues and I have done for the better part of 2 decades into viable treatments. I'm always asked, what is the timeline? Are we getting close? Will this protect people who are now worried about Alzheimer's disease, the growing number of folks in the baby boomer generation that are facing the threat of Alzheimer's and those who already have had it? The answer is that I think we're arguably 5, 7, maybe 10 years away from meaningful treatment. But having said that, we're actually only a year or 2 away from active clinical trials of drugs that come from the research that I've done. Well, the science bug really bit me during medical school. So before the science bug bit me, the healing bug bit me. But the science part really didn't dawn on me until I got to medical school. I should have recognized it earlier. Of course, medicine is science, but there was a whole dimension of studying molecules that came to light when I took biochemistry first year in medical school. And that's when I began making a bit of a transition from wanting to not only heal, but to understand the molecular basis of mental function. The power of science, the beauty of science is everywhere in our environment and all around us. And so our communities, our public, is often scared of science. It seems too obscure, too difficult to understand. But actually, if you take it step by step, like learning to play the piano or the violin, it's a wonderful lifelong avocation. You just have to start tuning into science when you're very young. So we need young scientists. And I can speak from experience in telling you that I have a daughter who is now in the throes of getting a PhD in marine biology. And she's struggling, as we all do, with, does she have the right hypothesis? Are the reagents going to work? Is her mentor available enough? Are there enough hours in the day to write this thesis, etc.? It can be challenging, but I would strongly encourage young people to think about what they can deliver to their fellow humans if they go into science.